All right, so I guess all of you have joined. Okay, I think I can start now. So good morning to all of you. Today we'll be discussing in connection with what we discussed in yesterday's class. And first, let me share my screen, and then subsequently I'll open the slides and start discussing. Am I audible? Am I audible? Hello?
Yes, sir, you are audible.
Yes, sir.
Okay, thank you. So as you can remember, what we discussed in last class was global environmental problems. Now, whatever we discussed in these particular slides, if you can relate them with the fresh water or fresh resources of fresh water, you will be able to understand that not all the time we get, pure water, right? So from there, the scope of protected water supply has come in the light, and we need to talk about this. So what is protected water supply? That we need to first understand. Basically, protected water supply means the supply of water that is treated to remove the impurities and subsequently made safe to the public health. Now, there is a very strong relation between the quality of water and the public health. Most of you know this thing, and when we say protected water supply, that means we are ensuring the quality of water, and so that it is not unsafe for the public health. Now, what happens is, when you take the natural water, sometimes it may be polluted with some physical agents or some, microbacterial agents that can be present in the water more than the permissible limit, or more than the limit which a human body can tolerate, and that can be harmful if consumed. On the other hand, this kind of water, if consumed, can create epidemics, and sometimes it can cause long-term disease, health disease, and all sorts of problem. Many of you might have studied during your environment and ecology also what may happen if we consider, or if we consume this kind of polluted water, and what sort of problem it can cause. Now, several heavy metal contamination and several other chemical contamination also can happen through this kind of, untreated water if consumed. So that is why protected water supply becomes very, very pertinent, considering that the water resources which are available in the nature are being disturbed or being polluted by us human being. And that is why, while consuming water from a natural resources, we need to ensure that the water quality is absolutely safe for consumption. So apart from that, what happens is poor sanitation in the hospitals. Not only hospitals, you will understand during the course of this particular syllabus that there are many ways water can get polluted. Like if I say, the mixing of leachate in the groundwater, that can create contamination. The biomedical leachate, that means the leachate which gets generated because of the biomedical waste, which is again getting generated in the hospitals, and then because of the poor sanitation of those hospitals, because of the poor drainage conditions, sometimes extra rainwater can come in contact with the biomedical waste, and thereby can pollute the water, and that water can go into the, it can percolate and can get mixed up in the groundwater table. And that is why United Nations in 1977 took this particular objective, like health for all by the year 2000. And it was kind of a mission, and India was one of the significant signatory of that particular conference, where this particular objective was taken into prime consideration. So from there, the potable water from protected water supply should be made available to the entire population. So this particular objective was evolved from that conference itself. Now, this potable water, you all know that that is the drinkable water and or usable water. So that potable water from the protected water supply should be available for the entire population. And from that concept, you will see that in most of the municipalities, cities, and these days even in the rural area of our country are getting very good quality water through some different schemes. In the if you say in the metro cities as well as in the tier 2 cities and all the other district cities, we have such kind of water supply scheme for decades. On the other hand, in the rural areas also, in most of the rural areas nowadays, this kind of schemes are being implemented to ensure that everyone, each one citizen of a particular country gets potable water from the protected water supply. Just hold on for a minute. Someone is waiting, I guess. Okay, so there comes the concept of pure and wholesome water, and that has to be supplied to the community alone can bring down the morbidity rates. And these morbidity rates basically the aftermath of consuming polluted water, which I have already discussed. Now with this, we will be talking about a bit about wholesome water before coming to this water supply systems objective of the community water supply. So okay, first let me talk about this and then we'll come to wholesome water and all. Provide wholesome water for drinking. That is the main objective of the community water supply system or community water supply scheme. So that is what actually I was mentioning. These are basically community water supply scheme. It may be urban, it may be rural. So regardless of that, the main objective is to provide wholesome water to the entire populace. Now, what is wholesome water? Now, let me throw some light on that. So, by now you all have understood one thing, that absolutely pure water is never found in nature, right? So there will be some amount of biotic components, at the same time some amount of chemicals, because see, water is there and it is in contact with either basically your hydrosphere and your lithosphere are actually in contact with each one of them or with each other, and that is where all the lithosphere contains huge amount of minerals, and that contains some inorganic chemicals basically which can get mixed in the water. At the same time, when we talk about soil, water, there is a possibility that some amount of biotic component will be there, and that is why once you take directly from any natural resources, that water cannot be called as absolutely pure water, and it cannot be found either. So what we get in the nature, we can say that it contains some amount of impurities in varying amounts. Now on the other hand, if you say the rainwater, that is originally pure and also absorbs various gases, dust and other impurities while filling, right? So this water, when moves on the ground further, carries sealed organic and inorganic impurities. So that is what actually I told you, like what we get is basically the end product, but when it starts forming clouds and then precipitation in terms of rainwater, that is pure, but then we are not getting or we are not collecting that fresh direct rainwater. So it percolates through the soil, and while percolating it carries a lot of sealed organic, inorganic impurities, minerals, and the removal of the turbidity, odor, and smell is considered as good, and the removal of dissolved substances is considered as chemically pure water. Fine. So these terms are very much, important to understand now. So what is good water, which is chemically pure water, which one is wholesome water, which one is potable water. So these are the things should be discussed over here. Now if I say chemically pure water, so that is considered as water which is not having any dissolved substances. However, removal of substances like calcium, magnesium, iron, sulfur, phosphorus, potassium, sulfate, and Hello? Hello? Is it okay now?
Yes, sir. Now is now it is on.
So, up to what point you could listen me? Can you please tell me what is the last thing you could listen?
So your second slide was going on for today.
Second slide was going on. So, could you hear, like you tell me in times, how much time you could not hear me?
So from last 10 minutes, we were unable to hear you.
Last 10 minutes. So you should
Yes.
have called me immediately. I don't know, there is a institute internet, there are problems. So anyway, I'll repeat it back again.
Okay.
So could you hear about wholesome water and potable water? No.
Sir, up to wholesome water we have heard.
Sorry. Can you please repeat again?
Sir, we heard only up to wholesome water. After that, the network went away.
So wholesome water means chemically pure water, wholesome water and potable water. All those things you could hear, right?
No, sir, only up to wholesome water. You were starting chemically pure water.
Okay, fine. Okay, fine. So if you don't hear, immediately you call. Fine, immediately.
Next time we will
Can you
take
see
care.
my screen now?
Yes, sir.
Can you see my screen now?
Yes, sir. Yes, sir.
Okay, good. So, yeah, we actually, what I was discussing is, before talking about the objectives of the community water supply system, it's better to understand the wholesome water. And not only wholesome water, different type of water which we will be using in this particular course. So let me discuss a bit on that. So as you might be realizing that absolutely pure water is basically a hypothetical situation. It is not practically found in nature. Fine. So two parts of hydrogen and one parts of oxygen by volume you will not get. So that's basically chemically pure water. So water which we get is consisting of several other components and with variable concentration or varied concentration. Is that okay? Now, so in the nature, the water which we get will have some amount of impurities present into it. However, if you see, the rainfall is absolutely pure or originally pure, we can say, because the process of getting cloud and then forming, or precipitating as rainfall is known to all of you, and that is why it can be called as originally pure water. However, we don't usually collect that water and utilize or to meet our demand. We usually don't do that. What we do is we let the precipitation go through the or percolates through the ground, and it basically recharges the groundwater table, and from there we take the water out and we yield out the water and we use for our own purpose. So this is the usual process. So that is why, despite of rainwater being originally pure, we are unable to get that. So what happens is it absorbs some amount of gases, dust, and other impurities while filling. After that, this water, when moves through the ground or percolates, it basically carries huge amount of silt, organic matter, and organic and inorganic impurities. And then depending upon the type of soil, the quantity or the concentration of those impurities can be varied. So the removal of the turbidity, odor, and smell is considered as good water in common sense. Right? So, if there is no turbidity, water is absolutely transparent. There is no odor and smell, so we can say by our physical sense that this water is good water. However, removal of all dissolved substances which is not otherwise seen in naked eyes, can be called as chemically pure water. But then one things would be remembered here, that removing all the dissolved substances like calcium, magnesium, iron, zinc, these kind of minerals, if you actually filtered it out completely, that is not good for health. So these days, that is why you will be observing one thing, that if you buy a particular purifier, water purifier, they will have provision to adjust the TDS, that is the total dissolved solid, because if you you take water which has very less TDS and all these substances are filtered out, then the water which you are getting is basically having no minerals or beneficial minerals, and that is why your body will be minerals deprived after a certain point of time, and that is why that water is not good as far as drinking is concerned. Now, these minerals are required to, for the growth of the tissue. At the same time, they actually maintain the hormonal balance to work properly during the proper time. So if you don't get all those minerals, you will have some certain amount of diseases. In other words, we can say that those minerals can prevent disease up to a certain extent. So therefore, we have understood that chemically pure water and good water is different than wholesome water. So now I am going to define wholesome water as the water which containing the minerals in small quantities within the requisite levels or within the permissible levels, and free from any harmful impurities. So that is called as the wholesome water. So by now you might have understood the difference between the wholesome water and the chemically pure water. Now there is another one term which we will be using frequently while discussing this particular subjects. So that is basically potable water. So the water that is fit for drinking, safe and agreeable, is called as potable water. So by sense, potable water is somehow similar to the wholesome water. And while talking about environmental engineering, while we will not be talking frequently about chemically pure water. Rather, in this particular course, mostly we will be dealing with potable water. Fine. So, in other words, we can say chemically pure water can be corrosive, whereas wholesome water cannot be corrosive because it should not have any harmful components present into it. So, this is what actually I discussed when the connection got disconnected. Now with this, having this fundamental idea of different type of water, we are now free to discuss about the objectives of the community water supply systems. So, am I audible?
Yes, sir. Yes, sir. Yes, sir.
So, hope all of you have understood, wholesome water, potable water, chemically pure water, and good water. So now, so main objective, as you all know, that main objective is to provide wholesome water for drinking to the entire community, or each and every consumers for their drinking purpose. Second is to supply adequate quantity to meet at least the minimum needs of the individual. So that is also very much important, as I discussed. So we have two things are there. One is an entire design period. Two is how many total number of populations are there. And the third one is individual demand. So until and unless we calculate the individual demand, it is very difficult to estimate the overall demand which is required for a particular society for the entire design life of the water supply system scheme. Fine. Number three, to make adequate provisions for emergency events like firefighting, festivals, and meeting. Now, regarding firefighting, I was mentioning in previous class also while talking about distribution system in the introductory class. So basically, we'll have some provision from the distribution system main pipelines, and while we have some fire accidents, we need water in huge quantity, and the discharge rate also has to be much more than usual. So that is why while designing the distribution system, you'll have to provision for firefighting. That is one part. Another one is in some places, if you see and if you consider even our country, in some places during some festivals, observe huge amount of population gathering in that particular area. So you should have those things planned before designing a water supply system scheme, that how much people, how much number of populations you are going to get in during those certain festivals, and accordingly you have to design things. Next is meeting. So if there is a important meeting, any sports meet, like I wanted to give one example, like Olympic is happening now in Tokyo. Most of you are aware about that. Now if you see, like a huge amount of population has come and are living for a couple of months over there in Tokyo for just to meet for their different purposes. And actually, if you see from a civil engineering point of view, now those who actually designed the water supply system, they had to envision that okay, we may receive this many people for a particular for certain months, and we should be able to, or our systems which we are going to design should be able to handle this many population for a particular term, which might be temporary, maybe for 15 days, maybe for 1 month, maybe for 3 months. But the objective is to create such smart systems or efficient system by which we will be able to handle this, this kind of emergency extra demand, and our systems would, should be acting as very much adequate during those emergency moment. Next comes to number 4 objective is to make provision for future demands due to the increasing population, increasing standard of living, storage, and as well as conveyance. Now what has happened is, if you see, like, once we design a particular water supply scheme, I mentioned like it has some design life, maybe 30 years, maybe 40 years, maybe 20 years. Now usually if we consider 30 years, now the population of today and population after 30 years will not remain same. So you have to do a logical population forecasting to understand what would be the future demands at your locality where you are planning to construct a community water supply scheme. At the same time, you need to understand the economy of that particular area, since it can change the standard of living of the people for the next 30 years, and that also has to be taken into account while designing this kind of systems. Now for certain reasons, you may sometimes store some amount of water while conveying water from one point to another point. There might be some loss, so all those things should be considered as the future demands, and that should be adequate for the future demands which we actually may encounter, maybe after 20 years, maybe after 25 years. So your system should not collapse by that time within the service life. So that is another one prime objective of the community water supply system. Next one is very, very important, to prevent pollution of water at source, storage, and conveyance. So this is very important. Fine. So what happens is, we have to ensure from the source to the consumption point, the quality of water remains intact. There is no change whatsoever which may happen during the process of, conveyance and as well as storage. So that is why we need to ensure that there is no pollution which can happen during all these different processes. Next is to maintain the treatment units and distribution systems in good conditions with adequate staff and materials. So the maintenance, periodic maintenance is most important, because what happens is, these things will be running for next 3 decades. So many things can happen. So proper maintenance is very much required for the proper functioning of this entire treatment plants, all the pumps which you are going to, other appurtenances, pipelines. So you should have adequate number of staffs and as well as the material or consumables just to maintain all those networking or all those water supply system components for that entire service life. And finally, to design and maintain the system that is economical and reliable. So keeping all the factors which I have discussed till now, and we have to do the economic analysis in the end, because see, the project which is not economical cannot be considered. So how much amount of money which you are going to spend, considering all the factors which we have discussed before, is very much important. At the same time, how you, being a municipal authority or being a government authority, if you are providing water, how you are going to generate the revenue is also become very, very pertinent in this context. And at the same time, the systems which you are adapting or the different components which you are attaching with the system should be reliable enough so that it can last for that long, up to the entire service life. So then what will happen is the maintenance cost can be minimized if we actually deal with reliable components of water supply system scheme. Are you able to hear me?
Yes, sir. Yes. Audible.
Okay. So that was the prime objective. Now slowly we will move to water demand. Right. So being a civil engineer, whenever you will be given a duty to design water supply scheme for a locality, first thing which you need to study is the demand. Right. So now we are going to discuss about different type of demands and what are the parameters associated with this particular demand, and accordingly we'll go ahead. So demand is basically the total quantity of water which is required for various purposes on that particular city. And as a matter of fact, the duty of an engineer is to determine the demand in the beginning itself and find suitable water resources, and that is very, very important. From which source you are going to take that much amount of water, what will be the after effect, how the water, the source is going to get recharged. Those things also needs to be considered. Now there are several factors which needs to be considered, or there are several parameters which needs to be considered while calculating or while determining the actual demand. And for that, here we can discuss about there are certain parameters which are generally assessed before calculating the demand, or maybe that can be called as draft. So anyway, so the first one is total annual volume. That is actually measures in liters or in million liters, depending upon the total quantity. Next come annual average rate of draft in liters per day. So that is basically V by 365. So you will get the annual average rate of drafts in liters per day. Next come annual average rate of drafts in liters per day per person. So that means now you need to understand, per day per person means you will have, this is what is actually called as per capita demand, small q. Right? So annual average rate of draft in liters per day per person. So this is usually expressed in unit of LPCD, liters per capita per day. So this is actually the annual average rate of draft in liters per day, so V by 365 per person. So again, V by 365 into 1 by total number of populations in that particular society is what is going to give you the LPCD value. Next one is average rate of draft in liters per day per service. So that is also important. So when we talk about per service, that is replacing per person. So then again the calculation becomes V by 365 into 1 by number of services. And then finally comes the fluctuation in the flows. That is expressed in terms of the percentage ratios of the maximum and minimum yearly, monthly, daily, and hourly. So that is basically corresponding to the average values. So how much more we are getting, how much less we are getting because of the fluctuation of the flows. So these are the different parameters which are recorded or assessed before chalking out the water demand for a particular locality. So before coming to different type of water demand, we should be necessary to determine the total quantity of water required for various purposes of the city. So certainly this is what is actually required. You need to understand what are the different ways water can be consumed. Now being an engineer, first duty is water demand, as I earlier mentioned, then to find the suitable water sources and accurately determine the actual demand. So many factors are involved. So considering all those factors, you will have to come up with a certain number of demand. Now, we have several certain empirical formula, thumb rules. They are employed to determine the water demand. Now, the various types of water demands we are going to discuss in details maybe in subsequent classes. So we have domestic water demand, industrial water demand, institution and commercial water demand, demand for public use, fire demand, and losses and waste. So domestic water demand is, you all understand, this is basically the household demand which is required in each and every houses. That also depends upon how many members are there in that house. So we'll discuss in detail in the next class. Next is industrial demand. So if a particular locality where you are planning to adopt water supply system, if there are some industries present in that particular industry area, so what would be the demand of that particular industry? Because industry demand is different than domestic demand, because sometimes water are also used for cooling purposes, washing purposes. So then it actually increases the overall demand in huge quantity. Institution and commercial demand, if there is a shopping mall present, if there are some institutions, some colleges, some big schools are present, then that will also have a very different impact on the overall demand. Now for public use, if you have some infrastructures, hotels and those things, then demand for public use also will come into the picture. Fire demand, that's a separate component which is always kept. And then losses and wastes. Now during the entire process, from the collection, treatment, conveyance and consumption, there are certain provisions where loss can happen and wastage can happen. So that also should be incorporated while actually determining the overall water demands. So with this, we'll stop here today and we'll discuss in the next class.